Good morning, students. We are going to see about log-based rollback recovery in Unit 4. The subject code is CS8603 Distributed System. So, what is log-based rollback recovery? So, this method completely uses the deterministic and non-deterministic events in a computation. So while doing one computation, we are categorizing the events into two types, deterministic and non-deterministic. Based on the type, we are going with a log-based rollback recovery. So deterministic and non-deterministic events means what? So non-deterministic event can be the receipt of a message from the another process, or it can be an internal event to the process. Why we are saying that the receipt of a message is a non-deterministic event means, so sometimes the message may be lost at the channel, or due to the network communication error, the receiver can't able to receive the message. So the receipt of a message is always a non-deterministic event, whereas the message send event is not a non-deterministic event. So such that we are categorizing the event into two types, deterministic and non-deterministic. So for example, the execution of process P0 is a sequence of 4 deterministic intervals. The first one starts with the creation of the process, that is this one. So we are seeing with the process P0. So it starts with the creation of a process. It is a deterministic process. Here also we have non-deterministic event, that is the message receive events M0, M3 and M7. So all the three are the non-deterministic event because it deals with the reception of the message, whereas we cannot say that M2 and M5 are non-deterministic events. They are deterministic events since they are the send events. Okay, like that for every process you have to differentiate the deterministic event and non-deterministic event. So what we are doing in log-based rollback recovery scheme means all the non-deterministic events are identified and their corresponding determinants are logged into the stable storage. That is, they are stored into stable storage. By storing the determinants of non-deterministic events, okay, we can recover the process during the failure. So this is called log-based rollback recovery. So during the failure-free operation, every process should store, every process should log the determinants of all the non-deterministic events. These determinants are stored in the stable storage. This is the assumptions what we have made in log-based rollback recovery. So here we have one problem, that is no orphan consistency condition. So let E be the non-deterministic event. It is occurring at the process P. We have to define three things. One is depend of E, another one is log of E, and the third one is stable of E. So what is depend of E? Depend of E. E is a non-deterministic event. So what all the processes are going to be affected by this non-deterministic event? So it is noted, it is denoted as depend of E. The processes which are dependent on the non-deterministic event E. So to find out the dependency, you can use the import happen before relation. And the second set is log of E. So that is the set of processes that have logged a copy of E's determinant in their volatile memory. So E is a non-deterministic event. So for that event E, you have to store the determinants. Before moving into the stable storage, initially it is stored in temporary storage, volatile storage. So what all the processes have the copy of E's determinant? It is logged in log of E. And stable of E, it is a predicate. It is a true or false condition. It is true if E's determinant is logged on the stable storage. It is false if we fails to log the determinant of E in stable storage. So these are the three things we need to find out the no orphans consistency condition. So what is no orphans consistency condition means? It is always no orphan condition. Okay. So a process P in N becomes an orphan when P itself does not fail and the state of P depends on the execution of the non-deterministic event E, but the determinant of E cannot be recovered from the stable storage, or the determinant of E is not available in volatile memory of a surviving process. Okay, if this condition is satisfied, you are saying that a process P is an orphan. Okay, can you understand? So when we say P as orphan, P state depends on one non-deterministic event, but that non-deterministic event determinants are not stored in a stable storage. It is also not available in a volatile memory. So if this happens, you say that the process P is orphan. Okay. So it is formally defined as for all E, if the non-determinant event E's determinants are not stored in a stable storage, it implies that the processes which are dependent on this E should contained in log of E, that is the temporary log. If the determinants are not available both in stable storage and not in temporary storage, then this is called orphan. Okay. So if we want a no orphan condition, then the determinants should be either stored in a stable storage. If it is not in a stable storage, it should be stored in a temporary storage. Okay, so that's all. Then we move with the pessimistic logging. So pessimistic logging, here we assume that a failure can occur after any non-deterministic event. So here we go with synchronous logging, that is whenever the non-deterministic event E is not stored in a stable storage, then you cannot go with any dependent processes. The dependent of E should be 0. So it is stronger than the previous one, the always no orphan condition. So in pessimistic logging, we go with synchronous logging. So this is an example for pessimistic logging. So that is a synchronous logging. What is synchronous logging? Whenever one process takes the checkpoint, it coordinates with other processes and it makes the other processes also to take the checkpoints. Okay, that is pessimistic logging. So if the processes P1, P2 gets failed after some point, then you have to find out the recoverable state from the log storage, and you have to restore, you have to resend all the messages. The third type of logging is optimistic logging. So in pessimistic we go with synchronous logging, whereas here we go with asynchronous logging. That is, each process no need to coordinate with one another. This optimistic logging do not implement the always no orphan condition. So here we use casual dependencies in order to store the dependencies. It requires non-trivial garbage collection scheme to remove the unwanted details. So what's the main difference between optimistic logging and pessimistic logging means? In pessimistic we go with synchronous logging, whereas in optimistic we go with asynchronous logging. And one more thing is, in pessimistic logging we are taking only the most recent checkpoint, whereas in optimistic protocol we have to take multiple checkpoints for each process, like this. For the process P0 we have 2 checkpoints A and D. For process P1 we have 2 checkpoints B and D. So like that, for every process we need to take multiple checkpoints, whereas in pessimistic logging, so it is not at all needed. We go with the recent checkpoint. So the last one is casual logging. So we have studied the advantages of pessimistic logging, advantages of optimistic logging, and the disadvantages also. So casual logging combines both the pessimistic and optimistic logging. So it is a more complex recovery protocol. So like optimistic logging, it doesn't require a synchronous logging. Here also we go with asynchronous logging. But like pessimistic logging, it allows each process to commit output independently and never creates orphan. That is, always no orphans property is satisfied by casual logging. Why it is called as a casual logging means, each process maintains the information about the events that are all casually affected its state. So that's why it's called as casual logging. So this is an example for casual logging. So what are all the events are equally affected because of this failure? They are all logged in the stable storage. Once the failure comes, from the logging we can recover to the most recent checkpoint. Okay. So that's about the log based recovery protocol. So once again, so under log based rollback recovery, so we have studied what is deterministic event and what is non-deterministic event. Then what do you mean by no orphans consistency condition? What is the formal definition of always no orphan condition? And what is pessimistic logging? What is optimistic logging? And what is casual logging? Okay. Thank you.